So a pentagonal pyramid of 25 mm sides of base and 50 mm axis length rests on HP on one of its corners of the base such that the two base edges containing the corner on which it rests make equal inclinations with HP. Draw the projections of the pyramid, and the axis of the pyramid is inclined to HP at 40 degrees and appears to be inclined to VP at 45 degrees. So this is the problem which is given to you. So here, since it is resting on HP, so obviously we have to start from HP. So here it is a pentagonal pyramid is resting on rests on HP on one of its corners. So the corner should be the end for the one end of the triangle in the front view has to be a corner. So the other end will be automatically it becomes a base. That is because since it is a pentagon, always the corner opposite is a side or the edge. So we have to place in such a manner that one end point should be a corner and the other end point should be a base or the edge. So why we have to consider like this? Because we have the condition that the two base edges containing the corner on which it rests makes equal inclinations with HP. So that is possible only when you consider the position such that one of the base edges is perpendicular to VP, then the opposite to that edge will going to be the corner. So here this edge AE and AB will going to make an equal inclination here with respect to with respect to this line. Similarly, you can see when you project it to the top view, you can see here this is the line to which the AE and AB will going to make equal inclinations. Now it is placed such that all the edges are resting on HP. Since all the edges are resting on HP, so that is the reason why it is parallel to HP. Since it is parallel to HP, so I am getting the true length in HP. So that means all the sides of the pentagon will be equal to 25 mm. So here A, B, C, D, E all are the base edges, so wherein which is parallel to HP, so I am getting the true shape. Now when you look from the front view, when you look from the top view, A, B, C, D, E is visible to the observer. So O is near to the observer, so O is visible, and O1 is away from the observer, so it becomes invisible. Since we have joined the slant edges O to A, O to B, O to C, O to D and O to E because it is a pyramid. So naturally we have to join from O to A, O to B, O to C, O to D and O to E. These are all called the slant edges. And when you look from the front view, ABC is near to the observer, so it is visible. A dash, B dash, C dash is visible, and D dash and E dash is away from the observer, so naturally D dash and E dash will be invisible. Similarly, when you look from the front view, O1 is hidden by the edge BC, so O1 dash will be invisible. So O is visible, so O dash is visible. Since O dash, now when you want to complete the front view, since we have joined between O to A, similarly you join between O dash to A dash, because O dash is a visible point, A dash is a visible point, so visible to visible is visible, so you dark this. Similarly, O dash to B dash, visible to visible, dark this. O dash to C dash, visible to visible is visible, so you dark this. O dash to O1 dash is a center line, which is an axial line, so you have a big dash, small dash, big dash, small dash. And when you look from the front view, the height is seen, so you have the height of 50 mm. So this is the analysis for the 3-dimension, how the object is being placed. Now we will going to write it in our orthographic view. So here first you consider a pentagon such that one of the base edges is perpendicular to VP, and you measure 25 mm here and mark this line. Then by using the protractor you measure an angle of 108 degree with respect to the included angle with respect to CD, and then draw a line. Similarly, with D as center, by using the protractor measure an included angle of 108 degree and then draw a line. Then with C as center, by using the compass, by measuring a distance of 25 mm, cut an arc on this. Similarly, with D as center, with a radius of 25, you cut an arc on this to get this point C and E, B and E. Similarly, with E as center, draw an arc, and with B as center, cut the previously drawn arc for a radius of 25. Then you mark this point as A. Then join A to B, B to C, C to D, D to E, E to A, which will be a pentagon. Then you need to find out the center. To find out the center, by using the protractor, you measure an angle of 54 degree with respect to CD. Similarly, with D as center, you measure an angle of 54 degree with respect to CD and then draw a line. These two lines will going to meet at this point, which will be called as O. Then you join and then you dark OC and OD. Similarly, you dark OA, OB and OE. So this will going to complete the top view. Then you project, draw the XY line and then you project all the points from A, B, C, D, E to the XY line. So when you look from the front view, A, B, C is near to the observer, so A dash, B dash, C dash is visible, and D dash is away from the observer, so it becomes invisible. So when you look from the front view, O1 dash will be invisible. So from O1 dash you measure a height of 50 mm because the height is seen from the front view, so you are going to mark the O dash. Then you join O dash to A dash, O dash to B dash and O dash to C dash, which is already explained. Then he says when the axis of the pyramid is inclined to HP at 40 degrees. Since the axis of the pyramid is inclined at 40 degrees to HP, so he has given the true inclination. But now first we have to see whether this axis is in true length or not. Since the axis is parallel to VP, so I am getting the true length here. So the inclination given is also true inclination. Therefore, you can transfer the first position front view here without any directly. So since he says that it is resting on one of the corners, I will going to keep A dash is on XY line. So then from here, since the axis is inclined at 40 degrees to HP, so the base will be inclined at 50 degrees to VP, 50 degrees to HP. So by using the protractor, you measure an angle of 50 degrees with respect to the XY line and then draw a inclined line. Then you measure the length from A dash to C dash. From A dash you cut an arc on this by using the compass to get this point C dash, D dash. Similarly, you measure the distance from A dash to O1 dash. From A dash you cut an arc on this to get the point O1 dash. Then you measure the distance from A dash to B dash. From A dash you cut an arc on this to get this point B dash, A dash. So here O1 dash is O dash O1 dash is perpendicular to A dash, C dash. So from O1 dash, by using the protractor, you measure an angle of 90 degree with respect to this inclined line A dash, C dash and then draw a perpendicular line. So you measure the length of this, which is 50 mm. From O1 dash you cut an arc on this to get this point O dash. Then complete the triangle exactly as similar to the first position front view. Then we need to write the top view. Draw a vertical projector from O dash to the top view and draw a horizontal projector from O to get this point O. Similarly, draw a vertical projector from A dash and draw a horizontal projector from A to get this point A. And draw a vertical projector from B dash and A dash and draw a horizontal projector from B and E to get these 2 points B, E. Draw a vertical projector from O1 dash and draw a horizontal projector from O1 to get this point O1. Then draw a vertical projector from C dash, D dash and draw a horizontal projector from C and D to get these 2 points. Once you get this point, all these points, then join all these points by using thin lines, thin continuous lines. Here join between A to B, B to C, C to D, D to E, E to A. Since we have joined O dash to A dash, O dash to B dash, O dash to C dash, O dash to D dash and O dash to A dash, here also you join that. Join between OA, OB, OC, OD and OE with all continuous thin lines. Then now we will going to apply the condition of visibility. So all the exterior edges of the boundaries of the solids are visible. So OB, BC, CD, DE, EO all are on the boundary, so you dark them. Once you dark them, then you have, when you look from the top view, OCD is near to the observer. Similarly, you can see here, when you look from the top view, OCD is a triangular face which is near to the observer, it is visible. So you dark OC and OD. Then we are left out with AE, AB and OA. Since OD is visible, so AE will become invisible because two visible edges cannot cross each other. Similarly, AB will be invisible because OC is visible. So the same reason holds good. Similarly, from a point, since A is not on the boundary, since the point A is not on the boundary, so A from A there are three edges which is emanating out. One is OA, another one is AE, and the last one is AB. So here AB and AE is already invisible. So from a point, if any one of the edges is invisible, so automatically all other edges will become invisible. So AB is invisible, AE is invisible. So naturally OA also becomes invisible. Since in the pentagon of ABCDE, AE and AB is invisible, so naturally O1 will going to become invisible. And you mark the center line from O to O1 is a center line, but first we have to give the priority to visible edge. Suppose if it is not there, then we have to give the priority to invisible edge. Then if that is also not there, then only we have to give the center line. Now since OA is invisible, from A to O1 you mark the center line mark.